This is TechSNAP, episode 368. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on May 15th, 2018. It is brought to you by our three great sponsors, iXSystems, Ting, and DigitalOcean. I'll tell you more about those as the show goes on. My name is Chris, and joining me every single week is my co-host, the technician, the engineer, and the teacher. It's Mr. Payne, Mr. Wes Payne.
Hello, Chris.
Hello, Wes. This week was the kind of week that TechSNAP was built for, so let's just get right into it and start with our warm-up story this week. And it's a story that takes us back to 1971, the HP 35, when HP had to go from the enterprise market to the consumer electronics market. They essentially cracked the market in this story, and it's the origin story of all of our gadgets and devices today, and it wouldn't have been possible without a big, old, traditional enterprise company.
Sometime in late 1971, Peter Nelson from HP's Corporate Relations Department enlisted Karen Cambria from the Automatic Measurement Division to pose with their new electronic device, a scientific calculator they named the HP 35. Now, HP didn't typically employ beautiful models, even if they were already employees, to sell their products. For their typical customers, corporations, hospitals, educational institutions, and government agencies, technical ads in trade journals or displays at trade shows were always more than sufficient. But for their new calculator, it was clear they were going to have to try something different. The economic downturn of the early 1970s meant that their normal customers weren't buying new electronic equipment. And to make matters worse, a market research study concluded that, regardless of the economy, very few would buy what was seen as an expensive slide rule replacement. So HP's marketing department decided to do something it had never done before. Instead of advertising in engineering and scientific journals, they would place ads in magazines like Esquire or Scientific American and sell the HP 35 by mail order direct to the customer. Now, that's all getting a little ahead of ourselves. Let's step this back a few decades. You probably already know this story. It was the height of the Depression. Bill Hewlett and Dave Packard, both recent Stanford graduates, decided to go into business together. They found a cheap rental in Palo Alto, just blocks from the Stanford campus, and in the garage out back, now considered ground zero of Silicon Valley, they began the Hewlett-Packard Company. Their first product, an audio oscillator that used a light bulb as part of the circuitry, was purchased by Walt Disney to help with the sound on his new project, the film Fantasia. Eventually, HP was offering so many products that it took a 4-pound, nearly 600-page catalog to describe them all. The Palo Alto garage became facilities scattered throughout the valley, then the rest of America, and finally Europe and Japan. By the mid-1960s, they were a Fortune 500 company with 9,000 employees. Tom Osborne, however, a Berkeley-trained electrical engineer, was not one of those 9,000 employees. In his Bay Area apartment, he was busy building a floating-point electronic calculator he called the Green Machine. He tried shopping around, but no one was interested until he showed it to HP in June 1965. Hewlett asked, "Can it do transcendentals, sine, cosine, that sort of thing?" Now, Osborne's Green Machine couldn't, but he replied, "Yeah, sure, why not?" And Hewlett was sufficiently impressed and convinced Osborne to stay on for 6 weeks as a consultant to see if he could turn his device into a proper calculator. At the time, HP was pretty new to digital design. Their first computer, the mini fridge-sized 2116A, had been released in 1966, and everything about the calculator project taxed their engineering and manufacturing abilities. "I was barely able to stay ahead of the alligators on my tail," Osborne recalled. His 6 weeks became 6 months, then a year, and then another. But finally, in early 1968, they had finished the 40-pound, typewriter-sized 9100A computing calculator. This wasn't enough for Hewlett. In what has been dubbed one of the most famous design briefs in electronics history, he asked Osborne to shrink the 9100. "I want it to be 1/10 of the volume, 10 times as fast, and cost 1/10 as much." Where Hewlett wanted the 9100 to fit in his secretary's desk return, he wanted this new device to fit in his shirt pocket. At the time, it seemed like an impossible request, but Hewlett didn't let the idea go. Here's some calculator history. First, there was the abacus, then the slide rule, then the adding machine, both mechanical and electric, and then finally, in 1961, the first all-electronic calculator, the 8-tube Anita MK7. By this time, however, the vacuum tube was really already replaced by the much smaller, more energy-efficient, and less expensive transistor that we've all come to know and love. The first all-transistor, or a solid-state calculator, the Freiden EC130, was introduced in 1963. 2 years later, Wang introduced the Loki 2, and in 1968, as we already know, HP released the 9100A. All these machines use discrete components, though, individual transistors and diodes soldered onto multiple circuit boards. Old school. The integrated circuit, multiple transistors etched onto a single silicon chip, what we know and love today, dramatically changed the industry. Osborne realized that these new chips were now small enough to realize Hewlett's dream. Work on the shirt pocket calculator began informally in November 1970, using an under-the-table budget. It soon became clear, however, that the entire project was going to cost around $1 million. That's when $1 million was really $1 million, as one engineer remarked. And that was kind of a big problem for HP. The sluggish, inflationary economy of the early 1970s really hadn't been kind. So after Hewlett heard the price tag for the calculator, he felt he owed shareholders due diligence and asked the Stanford Research Institute to do a market survey. Their conclusion was basically, we don't recommend that you go ahead with this. Not exactly what they wanted to hear. But eventually, Hewlett decided he actually wanted one. He wanted one, and he thought his engineers should have one as well. So on February 2nd, 1971, Groundhog Day, he gave the official go-ahead and with it, an official budget. The entire project took 14 months, half of HP's typical design cycle. When Hewlett received the very first prototype, he simply said, "It's about time. I've been waiting for this." The calculator was finished, but the question remained, would anyone actually buy it? They had run an informal name the baby type contest here, and it had several pages of suggestions, things like Athena, the math marvel. But when Hewlett saw the prototype, he just simply said the name would be HP 35, after the device's 35 keys. It didn't matter that HP's computerized inventory system only recognized 4-digit names. The HP-35 it was. Now, one thing I found adorable about this piece, turns out HP typically priced their equipment at the cost of the materials list multiplied by pi. Or if it's an especially competitive market, multiplied by E. And of course, the list for the calculator was really starting to add up. The chip cost more than $100, the LED display around $20. There was even the expensive plastic case, double injected keys, gold-plated circuitry. The accountants came up with a price of $395. 4 times the cost of a Japanese 4-function calculator and nearly 20 times the cost of a slide rule. But with a device, a name, and a price, the marketing department got busy. HP had always sold their equipment through field agents. This worked fine for their big-ticket items, things like gas chromatographs, other expensive purchases for hospitals or educational institutions. It was going to be a kind of a problem for a small device with a thin margin that they're trying to get wide distribution. So in a very unusual move, marketing sidestepped much of their traditional sales network and sold the HP 35 directly through the mail to customers. They did this with advertisements in newspapers, popular magazines, tons of places you would have never expected. Not in scientific journals, not even necessarily so much in trade journals or at trade conferences. To make this even more unusual, they sold it at retail. The marketing director had to subscribe to Women's Wear Daily just to figure out how to even start selling it in department stores. Once they had these distribution methods in place, January 4th, 1972, they finally announced the HP 35. If there was any doubt how well Hewlett's expensive slide rule replacement was going to sell, it quickly evaporated. Every engineer, every scientist, every mathematician wanted one. Students were literally selling their cars to afford it. GE asked for a quote for 20,000 units. Soon, HP couldn't keep up with demand. All in all, 100,000 HP 35s were sold in the first year, which accounted for more than half the company's total profits, and nearly 350,000 were sold over a 3-year lifespan. Now, of course, we've left out a few things from the excellent article Go find out more in the show notes, techsnap.system/368.
This really is the origin of the consumer electronics market, and it isn't lost on me that the cell phones that we carry in our pocket may owe a debt of gratitude towards the HP 35 and the way they pioneered selling electronics to the consumer market, because before then it was through thick catalogs that HP sold to existing customers, and this really changed the entire game. If you looked at any of the news or announcements out of Microsoft Build recently, it was all about Azure. Put everything up in the cloud. On-premises versus in the cloud is becoming a bigger and bigger debate. And there's a really great talk that we'll have linked in the show notes that got Wes and I talking about a problem that he's dealing with every single day, and it was something that Mike and I on Coda Radio were just discussing. The cost of putting infrastructure up in the cloud versus building out a large on-premises system, or perhaps a hybrid of both. And I loved this guy's take on it because he really ran some numbers, tried to figure out the cost-benefit analysis of, say, doing a large Kubernetes cluster on premises. And you played around with this too, right?
Yeah. I think it's a fairly common question, especially if you already have on-premise infrastructure. Maybe you've played around with Kubernetes. Maybe you're working with a team of developers who are used to it already, like the rich abstractions it provides for running services, especially in, maybe if you're using it in the cloud, you want to extend it to your on-premises infrastructure, or you're just wondering where you should start out and you're more familiar with on-premises infrastructure. It's going to be a lot simpler in the cloud, especially if you're running like a managed service. But once you have that, maybe you have latency concerns, maybe you have storage concerns where it just makes more sense to do something locally, especially if you already have experience.
I've found that the question is getting harder and harder to answer. The first few times it seemed obvious, but this was a couple of years ago. But now after watching Google I/O and Microsoft Build and Red Hat Summit, I come away going, it's a much more complicated question, and the cloud options are getting much more complicated, and it takes a considerable amount of time just to get some of those things set up now, which used to be the big promise. Oh, just go throw it online and it'll be up and running and you have new infrastructure that's ready to deploy whatever you want. The reality is, though, it takes a lot of engineer time to set that up correctly because it's becoming very complex.
Yes, definitely. And that's why I thought this talk was just great. It was at KubeCon by Dmytro Dajchuk. He works for Pax Automa. And it really just lays into... it's not a 200-page report. It's not going to be everything you need, but it can give you an idea at the outset of what does it actually take to take a traditional infrastructure design data center and lift it up to something like platform as a service, or at least infrastructure as a service, where you can run Kubernetes, where you have this set of APIs you can work with, and you don't have to think about provisioning storage for an individual machine or managing a bunch of DNS and static IP addresses. Instead, you're talking about, making services and managing pods. And if you're just starting out, or, if you're not that familiar with running a data center, or you're not that familiar with Kubernetes, or both, there's a lot of things to consider. Things like servers, network fabrics. You just actually have to have physical racks and PDU set up, all that standard physical stuff. And then probably you're going to need inventory management, a time server, something to provision your OS. You're going to need configuration management. You're going to need probably something to orchestrate your containers, probably Kubernetes in this case. Software-defined networking is going to be involved. Of course, you're going to want monitoring and alerting, right? Logging, converged storage. You can't use local storage. That doesn't work in the cloud area. So you're going to need something like Ceph, or maybe a really expensive SAN device from some expensive manufacturer. Mm-hmm. Not to mention backups of all of these things.
Yeah. Oh, for sure.
And then maybe you want to go a little above and beyond. You really want to get the benefits of something first class. Well, you're going to need some sort of request tracing, service lookup, user management, secret storage.
I was thinking that too, yeah. It gets really complex after a while. Either way you go, really.
Oh, yeah, absolutely. And it's not like, just like you're saying, it's not like that it's also not complex in the cloud, because of course it is. This is just a complex space because we're running very complex applications. But you should know there's additional complexity if you're going to replicate all of those things yourself. And it just gives you a nice peek into what your cloud providers are doing for you behind the scenes. You don't get a lot of visibility. You kind of pay not to have that visibility, but there's a lot going on. Now, all of that may have you a little bit down on trying to go through with something like this. But there are, of course, a ton of benefits. And what I think is nice in the article here is it's all laid out. He's made some assessments. They're just rough numbers, but it gives you an idea of how much time you're probably going to need to spend thinking and implementing these things. And if you get it right, like once you've got this down, if you actually have, the people power teams of knowledgeable people to run this, it can work very well.
Recently, some security researchers published a paper named EFail, which claims to have broken SMIME and OpenPGP encryption, and the EFF has even gone as far as to recommend immediately uninstalling Enigmail. So we're going to break down EFail TechSNAP style, who disclosed it, what it is not, and what some of the early reactions have been. Take it away, Mr. West.
No, PGP isn't broken. EFail is research by a team of Danish and German researchers, which really identifies some flaws in the implementation of open email encryption standards. And when configured in the way that a lot of common clients are, complete exfiltration of decrypted data is possible.
Right, so it's not actually a flaw in OpenPGP or SMIME, as it's been reported almost everywhere.
Right. Really, it's problems in the implementations of particular email clients. Obviously, encryption is incredibly complicated and important to get right. What's happened here is that the settings, some of the default behaviors, some of the default interactions in these email clients really are not secure and can allow, given a dedicated attacker, complete exfiltration of encrypted data.
My understanding, though, is it has to be fairly targeted. In a sense, you have to almost be fully aware of what their capabilities are and what maybe even email client they're using. Is that true?
Not necessarily the email client, although you would need to know that it's one of the email clients that implements this behavior. And really the problem becomes this integration. If you simply receive encrypted email, extract the encrypted content, and then decrypt it with, let's say, GPG on the command line by yourself, you're not affected by this at all. Keep doing that and you'll be fine. The problem comes if, let's say you're Chris and you love sending encrypted email, but you also hate having to go manually do those steps. So you've configured Thunderbird to automatically decrypt these for you.
That is actually something I've done.
Yeah, there you go. You're a perfect example. Thank you, sir. I'm sending you an encrypted email. Cool new stuff for the next TechSNAP. I don't want anyone else to see it. So I encrypt it on my side, send it to you. Normally, right, you'll receive the email. Thunderbird works its magic. If you've already got your keys loaded and everything, then poof, you can read my message, no trouble. But let's say there's some competitor show out there. They really want to see what's in that document. If they are able to somehow intercept my email to you, well, they won't, unless they've actually stolen your key, they won't be able to read that message. Of course, they'd like to. What EFail allows, if you're using a vulnerable client, it sounds like maybe you are, there's actually sort of two different attacks, maybe three if you want to get technical. But the basic idea is they can construct a wrapper message around that encrypted text, send it to you, and then if your email client, let's say, has HTML enabled and they've wrapped that in, one example is just a simple HTML image tag, they can set it up so that it's a broken up image tag with the start at the start of the encrypted text and the end at the end in such a way that the source of the image is actually formed into a URL. And so once your client tries to render that image after decrypting the content, the entire decrypted content gets sent to whatever URL is configured.
So if I had just listened to my old man tendencies and left HTML emails off completely in Thunderbird, even though I have a vulnerable configuration, if I was sticking to plain text, this wouldn't have been a problem for me.
Well, that's where it gets a little complicated. The authors actually identified a ton of different exfiltration back channels, so you'll have to get into the weeds, but the HTML routes are some of the easiest exploits. So that's definitely a step in the right direction.
I see. Okay, so there could be some possibilities, but the circumstances get more and more rare.
Exactly. So to your earlier point, yes, it does require somewhat of a targeted attack, right? There does need to be some sort of man in the middle or an interception, or maybe it's just someone who has taken over an email server. For your day-to-day emails, maybe not a huge concern, but obviously if you're taking the trouble to encrypt them, something like this could be a real threat. The scheme I've just described is an example of the direct exfiltration attack, and really it's just something it's behavior that the client sides end up needing to fix, because There's just, if someone can intercept your email and send these specially crafted and modified messages, that default user interaction, especially with rich HTML or any of the other back channels, this is just going to be a danger that we have to deal with. There's also a second attack, which the authors have dubbed the CBC/CFB gadget attack. And basically the idea is this. Really, it's sort of two different attacks. One of them is an attack on OpenPGP, and the other is an attack on SMIME. And the idea with both is the particular encryption schemes chosen by those specifications and used by these clients can allow an attacker, if they know enough about the plain text that's been encrypted, and let's say they know like enough of like maybe there's a header or some sort of standardized piece of plain text in there, they can actually, due to some weaknesses in the scheme, precisely modify that plain text. So in this case, they're able to cleverly craft up, basically just modify the encrypted text because they know some of the plain text in such a way to add that same image tag inside the encrypted text. So you don't even see anything wrapping or suspicious in the email. You just get a different blob of encrypted text. Once it's automatically decrypted, boom, that image tag appears in the decrypted text, and then all that plain text is sent in the exact same way.
That happens without the user even realizing.
If you've configured it automatically, yeah. A key difference between the attacks is that if you're just following, for example, the SMIME standard as a client implementer, then you're probably vulnerable to this. And each vendor may, especially because it's inside the encrypted text, so you may need to come up with different mitigations depending on the client. It's not as easy as some of the mitigations to the first type of attack are. So in the long term, it's probably necessary to update the specifications, or at least like the schemes and settings that are being used by clients. Now, one key difference here is that if you're a standards compliant SMIME client, you're probably vulnerable to this, and you may have to come up with your own unique set of mitigations that may or may not prevent the attacks. It's more difficult because the modifications are inside the ciphertext, not just wrapping the ciphertext. It's probably a lot easier to just identify like, oh, here's a block of encrypted content inside an image tag. No, let's not do that. Or, you could short circuit that behavior in a lot of ways. If it's inside the ciphertext, that's a lot less trivial. In the long run, it's probably necessary then to update some of the standards, or at least the choices made in the encryption schemes and parameters used by popular clients.
So if you're wondering if your mail client is impacted by this, the researchers in the paper that we have linked in the show notes did list all the mail clients they tried and kind of give a good spread of which ones are affected. So you can check against that. But I guess my next question would be, Wes, is there mitigations or steps we could do now? Any recommendations to at least let us continue to use encrypted email? Because the thing I didn't really appreciate in this whole thing was the EFF's whole stop using encrypted messages, and it was a little overhyped. So what can we do now to keep using encrypted email?
Right. I mean, if you need to send encrypted email, you probably still need to do it, and there may be time-sensitive applications. Step one, short term, just don't enable decryption in your email client. Separate those two out. Have your email client receive emails, take that email as data, and then feed it into something that just decrypts encrypted data. That's simple. It doesn't have a nice, clean UX. It's a lot more difficult. You probably need to know a little bit more about what's actually happening, but you'll be safe. Another less complete mitigation, disable HTML rendering. We all know HTML emails are gross, and yet we do it anyway. I'm just as guilty, but if you can get away with it, just disable HTML rendering. That won't completely mitigate things, but most of the common and easy examples of EFail will be mitigated. Longer term, we're just going to need some patches to a lot of these clients to make their default workflows secure to these sort of attacks. That'll take some time. And then even longer term, hopefully we'll understand as a community what's going wrong here is what parameters need to be set, what do email clients need to do to implement these encryption schemes properly.
Let's talk about the reactions for a moment, because I think they prove that classic point that encryption is hard to get right, because it's more than the math. It's all of the implementation around the math. And when you look at the coverage and the responses to the coverage, people got really fired up that this was being called a flaw in OpenPGP.
Yeah, definitely. And I think that's an important clarification, at least in the OpenPGP case, is this is not a case of you running some function that the OpenPGP team or GNU PG or any of the people behind these pieces of software are saying is secure. And then it's somehow not, right? It's not a bug at that level. It's what settings and features, which pieces of encryption with what ciphers, what settings are you actually using, and are those secure? So there was a great response by the GNU PG and GPG4Win teams specifically about OpenPGP and GNU PG's involvement in this vulnerability. And they really kind of lay it out, I think, in some pretty clear terms, at least for that side. They don't comment on S-MIME. That's somewhat of a separate issue in this case. They really clarify that this attack targets buggy email clients. They also point to some history that I wonder, do email clients not understand? I wonder also, were the researchers well versed in this and it's just they didn't mention some of the complications here? I'm not sure. I'm sure we'll find out more as this evolves. It's all still very new. But they write, back in 1999, we realized OpenPGP's symmetric cipher mode had a weakness. In some cases, an attacker could modify text. They had a discussion about it back in 1999, and then about a month later, they had a first version of their countermeasures. The countermeasures they created are called the Modification Detection Code, or MDC. It's been a standard part of GNU PG for almost 18 years. And that's where they really clarify that this is an attack, at least on the OpenPGP side, against buggy email clients, because correct use of the MDC completely prevents the attack. Basically, if you're using MDC, you can't do that second type of attacks modification on the ciphertext. It's just not possible. And so then the only thing left is the direct exfiltration attack, which, as we've mentioned, is basically something the clients need to fix. Now, one client that isn't vulnerable is Proton Mail. Over on their blog, they've got a great write-up detailing all the technical reasons why they're not vulnerable, and a great breakdown of EFail in general. Good examples of just what's going on here, things to watch out for, and some handy guidance. You can find all that in our show notes, techsnap.systems/368.
Yeah, we'll really have links to everything we've referred to this episode. This has really been our first look at EFail. I don't know if it's going to go anywhere from here, but we'll keep watching the story. And if anything significant develops, we'll cover it right here on your TechSNAP program. This episode of the TechSNAP program is brought to you by DigitalOcean. Go to do.co/snap and get a $100 credit when you sign up with a new account at DigitalOcean. Simplicity at scale. You can spin up infrastructure on their super fast, all SSD-based systems in less than 55 seconds. They have data centers all over the world, a dashboard that is so brilliant, it'll blow you away, and an API that's simple, clean, and well documented. Speaking of documentation, they have lots of guides, tutorials, and a community that has written tons of open source software to help you take advantage of DigitalOcean. Deploy an entire system and stack, or just the base rig and build it from there. do.co/snap and try out their new flexible droplet plans. For $15, you can mix and match resources to your perfect application needs. do.co/snap. And by iXSystems. Visit iXSystems.com/TechSNAP to learn more about this incredible company and grab the white paper that helps you better understand and help management better understand why you might want to move to iXSystems. They'll white glove build solutions just for you from the beginning all the way to the end. They can build the perfect system. And I often talk about all of the large enterprises that use iXSystems, but I want to take a moment and talk about how iX can be great in education. I have a real soft spot for that, and students and administrators would love some of the features of the true NAS Unified Storage Array. It has both NAS and SAN capabilities. It supports both block and file protocols, and that level of flexibility gives you a huge range of choices of applications and implementations, which is critical in an education deployment. But really, they have solutions for all walks of life: small business, huge enterprise, massive government institutions, or maybe even a local school. Visit iXSystems.com/TechSNAP. They're the leaders in providing hardware and open source solutions that work together, and they give you great support from beginning to end. Having worked with iXSystems for years now, I can tell you there is no other company, no other place I would go for storage or servers or solutions that are driven by open source. iXSystems.com/TechSNAP. And by those cats that are rebooting mobile, Ting. Go Go to techsnap.ting.com. It's smarter than unlimited. If you use less, you just pay less. The average Ting phone bill is just $23 per month. It's really simple. $6 for your line, and then your minutes, your messages, and your megabytes. However much you use, that's how much you pay. They have nationwide coverage, CDMA, and GSM, and there's no contracts. There's no lock-in, no quote-unquote agreements. It's just really simple, and you're always in control the entire time. You can log into their control panel and check your usage. You can take complete control over all aspects, all individual service aspects of your account. You can set usage alerts, which is great if you have younger ones that you're giving service to. And with CDMA and GSM, that means there's lots of devices you can bring, and then they'll give you a $25 service credit. Likely you'll pay for more than your first month. Or go grab a device from Ting and take $25 off the cost of the device. Ting is now selling the Moto Z2 Play. That might sound familiar. The Moto Z2 Play is the modular Moto phone that's been in the works forever. Moto mods are actually shipping. Snap-on additional cameras, batteries, there's a JBL speaker out there, and more. That's really going to get some life out of that phone, and I'm curious to see how that works. Plus, the Moto phones have a great Android experience, and you can get it directly from Ting. Just start by going to techsnap.ting.com. It's how mobile should be. If they were going to reboot the industry today, this is how they would have to do it, and Ting's making it happen. Go to techsnap.ting.com.
Thank you for going to techsnap.systems/contact to send us all of that wonderful feedback. Or, hey, a war story, just like Eric did. He writes, I came into my current company via a boss I had previously worked with. What I didn't know was that right before I got there, he had cut a bunch of jobs as well as salaries. So the second I showed up, I was the black sheep. So then the lead sysadmins, they sort of just forgot to give me access to servers. I, of course, followed protocol at first, but it quickly became very daunting. The sysadmin was a huge Unix geek and despised Windows. I'm sure something many people can understand.
No.
Fortunately for me, we had some Windows servers, and he was a password reuse offender. So I cracked his password on an unlatched Windows box and gave myself permission to all the servers that I needed to do my job. Fast forward 1.5 years, he finally figured it out. Fortunately, by that time, my new boss and I were quite close, and I only got a slap on the wrist.
When I saw this email come into our inbox, I literally had a moment where I thought this was a troll, that this was a former coworker that I had worked with that was trolling me.
Really?
Yeah, I worked at a place where a guy came in from a previous job. He cut a whole bunch of jobs in IT, and then he brought in from these previous jobs his best buddies. And they were the black sheep because they were not necessarily trained up. They didn't really have the same skill set.
They've just replaced people you've worked with.
I think I may have forgotten to give a few passwords from time to time.
Whoopsie. Thankfully, there's resourceful people like Eric.
Yeah.
Not even that'll stop them.
No, it didn't. And they just got the job done. And really, I think in the end, some of them are still working there. So they've been working there longer than I have. They kept the job.
Thank you also, Eric, for writing in. That's a great story.
Steve also writes in with a war story. He says, when I was doing netware adminning in the 90s, I was working with a new office fit-out that we had just finished installing, the comms room and brand new HP net servers and network gear. There was also a plumber and his apprentice working on the water-based fire suppression system.
Uh-oh. I don't like where this is going.
No kidding. This just took a turn. He says, to this day, no one is still exactly sure what happened, but the plumber and apprentice both went to the main shutoff valve, and when they turned on the fire suppression system, it failed and flooded the entire comms room.
No.
The water flowed for almost 20 minutes, and no one knew where the plumber or his apprentice were. Once we found them and had the water switched off, we began to assess the damage. The underfloor breakers had tripped early, so the damage was minimized. However, the DDS3 library was completely flooded and never worked properly again.
Oh, no.
The 2 HP net servers were fine. We took them apart, we let them dry out for a week, and then we fired them up, and they posted okay.
Amazing.
The switches also were fine. However, we did get the mains power equipment and UPSs replaced just to be safe.
Yeah, I think that's reasonable. That's crazy.
Wow, Steve, I can't believe you managed
20 minutes?
Oh my gosh. Could you imagine how excruciatingly long
Running around pulling your hair out? Where did they go?
Longest 20 minutes of his life, I bet. Well, I'm not so sure about that, but at least of that job.
I hope so.
And they managed to save those 2 net servers and the switches, which is mind-blowing.
Congratulations.
That whole time of letting them dry out is like the gamble that you hope pays off. That's a great story. If you'd like to send in your story, or if you have a question or thoughts on anything, or maybe a great tool our audience should know about, please visit techsnap.system/contact and send that in to us. We love getting them.
That brings us to the end of this week's program, but before we go, we've got a quick PSA for those of you in the corporate world.
Cisco is announcing a rather nasty bug in part of its WebEx conferencing software. It's bug CVE 2018-0264, if you want to look it up. And it's specifically in the platform's recording player for advanced recording format, the ARF format. There's a recording aspect and a playback aspect. When you play back, a player gets automatically installed on the user's computer, and that's where things go south because there is an exploit in that player that the attacker could take advantage of. We've got information in the show notes, but also in the show notes, which might be more appealing, is since there's no known workaround right now and the patches haven't been pushed out, we'll also link you to a tool that's been created by Cisco to completely remove all WebEx stuff from your machine. All of it. Just does a complete uninstall, and you need their specialized tool, and we'll have a link to that.
That sounds great. I don't think I have any WebEx installed. I just might run the tool anyway.
Just to make sure it's all
clean.
All right, well, you can find Wes on Twitter. He's at Wes Payne. I'm at Chris LAS, and the whole network is at Jupiter Signal. And also, if you're going to be at Texas Linux Fest in Austin, Texas, June 8th through the 9th, come say hi. Let me know. Send me a tweet at Chris LAS again. I'd love to see it.
You can find even more TechSNAP with our RSS feed, techsnap.systems/subscribe.
Thank you so much for tuning into this week's episode of the TechSNAP program.
See you next week.